All right, here it goes.
1, 2, 3, go!
This is my boat. That's my friend. My name is Preston Palmer, student engineering. And before I play the rest of that video, I want to show you what's under the hood of this thing. So this boat is pretty much 3D printed as much as it can be. And it is controlled by this FlySky i6X. So we've got 3 screws here to hold on the lid, and here under the lid we've got our little pieces here that hold on the electronics box, and I've had it disconnected so that I can show all the parts in here. So we've got here our battery, our speed controllers, and the receiver with 2 switches and the connection for the battery, and our antenna. And we put it all in this box so to keep it, all the components in there, dry. And then inside the boat we have our 2 turbines, and they suck water in here through the bottom and then spit it out the back. And then because the rudder is in between them, it can direct those flows and make it spin or turn with pretty tight radius. And I've unglued one of these turbines to show you how that all works. There's 2 parts here, 3D printed, and they just slide together. And on the top we have our piece that holds the motor and the propeller. The propeller spins, it sucks the water in and pushes it out the back. And so there's the 2 holes in the boat that are printed so that the water can enter and exit. And then, like I mentioned before, we have the rudder, and it's controlled by the servo motor just to go back and forth, just connected with a paper clip. And so there it is. It's pretty simple, but I found that the simpler a design is, the better it tends to work, especially if you're working with imprecise materials such as 3D printed plastics. So I'm going to show you the rest of the video clip of those 2 boats racing, and afterwards I'll explain some of the engineering behind all this.
1, 2, 3, go!
So the boat didn't go as fast as I wanted, but it still worked pretty good. It kept out water pretty good, and it continues to function. We're doing this for this project for a class, and so we were given these 2 motors. We could only have 2, and we were given the servo and all the controllers. So we didn't get to pick all that, but we were just trying to do the best we could with the motors that we had. So we did a lot of testing to find out how big our propellers could be to push the most amount of water. Also, how many fins we could have. We tried 4, 5, and 6 blades for our prop. We found that even though 6 blades on the fan pushed out a more laminar flow, we found that 4 blades pushed more and had more force behind it. So we stuck with 4 blades, and it all ended up working pretty good. I think the reason why it didn't go so fast is because the boat is pretty heavy, and so it sits low in the water, and which creates a lot of drag that has to push through. And so if I were to redesign this, I would make it quite a bit lighter, print the walls of the boat quite a bit thinner, and just try to maximize the weight I could take out to keep it more buoyant. So there's support material, there's some pieces right here that hold on the servo motor, and then with the lid we just cut some holes in the back for the opening for the rudder control from the servo, and then a hole in lid for the antenna to go through. And I think if I were to redo this, I would definitely improve the lid, how it attaches, and I would also, the main thing I would do would be to improve the turbines and how they function, because we struggled a lot with getting the propellers to stick to the shaft of the motor. Oftentimes it would come unstuck. It would just, the shaft would spin inside of there because it came loose of the propeller. So we had to tighten the diameter of that hole where we shoved the shaft of the propeller through. And that made it hard to get it on, but in the end, after maybe like 20 propellers, having printed 20 propellers, we finally got it to where it was working and doing it every time. And so if I were to redo this, I would make a bigger hole in the bottom and just make the turbine out of one piece, and then have a lip on the edge of here where I could put a O-ring or something rubber under there and have bolt holes in there where I could tighten it down to the bottom of the boat, and have another piece on the other side that would make this hole smaller where it sucked in the water. And that way we could take off that piece and access the propeller instead of having to take off all the glue and then get to it. It would be a lot easier if we just take out the bolts. And I think that way it would also be more watertight. For the most part, this kept the water out, but it wasn't perfect. And the hot glue does come off pretty easily. So I would do that to make it so that the water didn't come in. And I would do pretty much the same thing for the back. Have it so it bolted. But the problem with that would be that it would have to make the boat wider. And so that is another kind of thing we'd have to work around. So other than that, this boat worked pretty good. I am happy with how it turned out. It didn't go super fast, but I'm still happy with it. So if you like this video, hit that like button, subscribe to my channel. I also make a lot of tutorial videos that you can check out, learn about your engineering classes, get some help with that. So far I've been making a lot of statics videos, but I'll also be moving into dynamics, mechanics of materials, physics, calculus, and all those classes that engineers take. So check that out on my channel. If you like this, hit that like button, and thanks for watching.